Hello everyone, this is chapter review, first chapter 1 review, page 28. This is page 28, guys. So we solved the first 9 questions at school, if you remember, from question number 1 until question number 9. So here in this video, I'll try to solve the rest of the questions. So I start with question number 10. Now, question number 10 in your book, it says, find the SI unit for energy for Einstein's famous equation. Now, Einstein's famous equation, it says E equals mc squared. What is the SI unit for E in Einstein's equation? SI unit. Let's try to find that. Given the fact that we know m is the mass of the object, here in this equation, m is the mass of the object, and c is the speed of light. Speed of light, L. All right, so we know those two informations. From those two informations, we will try to find out what is the SI unit for energy, for E in Einstein's equation. All right, let's solve the question. So first, I'll write down the equal sign. Now, m, which is the mass of the object, what is the SI unit for mass? The SI unit for mass is kilogram, of course. Then you multiply it by the speed of light. What is the SI unit for the speed? All right, the SI unit for speed is meter per second, but this is not speed, of course. This is speed squared. So I have to square this units here, guys. I have to square the numerator. I have to square the denominator. So that's right. Speed is equal to meter per second, but speed squared equals to meter squared per second squared. So this will be my final answer. This is the SI unit for energy in Einstein's famous equation. All right, so that's question number 10. Let's move on to question number 11. So in question number 11, it says, express the following. Express each of the following as indicated. So number A, it says, I've got 2 decimeters. Change it into millimeter. All right, so that's simple. We just do the conversion of units. But before we solve the question, here, as you can notice, that we've got double letters, dm, mm. So those are both double letters. Now, we had a technique to solve that. We said if we had double letters, we will just try to first change one of those double letters into single letters. So I'll change this one to m, and then I'll change the m to millimeter. That's how I'm going to do it. I'll do it in 2 steps. And that's our structure. Let's first do the first part. Here, the first step. I've got 2 decimeter. I'll change it to meter. That's my first step. And how am I gonna change that? I'll just simply write down the input here, 2 decimeter, multiplied by the division. And my division here in the denominator, I'll have decimeter so that they can cancel out each other. And on the numerator is my output, which is the meter. Now, which one is the single letter? The meter is the single letter, and I'll write down the power next to it. What is the power for D, for deci? It is 10 to the power minus 1. All right, so that's all. I'll just write down 2 multiplied by 10 to the minus 1 meters, which means, if you simplify this down, it means 0.2 meters. That's what it means if you do your calculation. All right, so that's the first step. Now let's do the second step. The second step is we will change meter to millimeter. That's what we're going to do now. I've got my meter, this number 0.2. Let me change it to millimeter. All right, so let me change that. I've got 0.2 meter. I'll change it to millimeter. Okay, I'll first start with the input, of course. As always, 0.2 meter multiplied by my division. In the denominator, I have millimeter. No, sorry, in the denominator I have meter, so that the meters can cancel each other out. And what I want is the output, which is millimeter. That's my final answer. I have to write down my output always in the numerator at top. Okay, so which one is the single letter? Of course, m is the single letter, so I'll write down the power next to it. That's our structure, that's our method. So what is milli? Milli is 10 to the minus 3. All right. So that's what milli is, 10 to the minus 3. but I don't need powers in the denominator, so I'll have to take it all the way up. I never need powers in the denominator, so I take it up. All right, so this is our 0.2 multiplied by 10 to the minus 3 will become 10 to the positive 3, because once the denominator goes to the numerator, the powers will flip. The sign will flip. If it's negative, it becomes positive. Let me write down positive here, although it's not necessary. But this is what it turns. It becomes 0.2 multiplied by 10 to the power 3. That's the answer. So I can write down in a better way. I could just simply write down. I can take this. I could take this here. Not there. I could change this to 2. That means I made this number to look bigger by 1 factor. So I'll have to change the power smaller by 1 factor. So that's positive 3. I'll just minus 1. I make it less with 1 factor. So this will be positive 2. All right. So I have got 2 multiplied by 10 to the power 2. That's also true. This is also true. That was also true. I could have just left it there. I could have just left it there. I could have just said 0.2 multiplied by 10 to the power 3. That's also true. Positive 3. But this is a more good-looking answer. This is a more proper way to write down the answer. So that's it. But guys, let's not forget to write down the final unit, which is the millimeter. That is what the final answer is. You should write down the unit at the end. If you do not write down the unit at the end, then that means you did nothing, because our goal is to change it to millimeter. All right, so let's go to B on question 11. B says 2 hours 10 minutes expressed in seconds. Now this one is probably a bit challenging for you. 2 hours and 10 minutes. Change it to seconds. All right, change it to seconds. So how are we going to do that? Now, first, I need to, so in order to change it to seconds, first you have to change those to minutes, and then change it to seconds. Now, this is minute itself, so I'll just leave that for myself here. I'll just not touch it for now. I'll just touch the 2 hours. When I change the 2 hours to minutes, I'll add them together, and then I'll change them to seconds. That's how I'm going to do it. So I'll first just deal with the 2 hours. Now, what is 2 hours? How I'm going to change 2 hours to minutes? Let me change 2 hours to minutes first, then I'll change it to seconds. 2 hours to minutes, how am I going to do that? Simple. You just write down the input, and here you have the denominator, which has to have the same unit, guys. If this is hour, this has to be hour so that they can cancel out each other. Now, 1 hour, every 1 hour is how many seconds? How many minutes? Sorry. Every 1 hour is 60 minutes. Every hour is 60 minutes. Okay, so 2 multiplied by 60. How much I get? I get 120 minutes. That's what I get. 2 hours is 120 minutes. But I have an extra 10 minutes as well. So I should write down this here. 120 minutes plus 10 minutes. How much I got? I got 130 minutes. So I changed it to minute. Now I want to change this minute to second. And how am I going to do that? Of course, I'll start with the input. This is my input now. And I'll change it to second. All right, so the input multiplied by the division. My division should be, of course, in the denominator, I have minutes, so that minutes cancel out with minutes. Okay. And what should be my output? Of course, second should be my output. So I'll write it in the numerator. Now, 1 minute is how many seconds? 1 minute is 60 seconds, of course. 1 minute is 60 seconds. I'm pretty sure you all know that. 1 minute is 60 seconds. So I'll multiply 130 by 60. So this will be our final answer. So that would be, if I do the multiplication, that will be how many seconds? Let me see. I've got 2 zeros when I multiply them, and if I multiply 6 by 13, let me see how much I get. So I get 60 here, and here I get 18, so that will be 7, 8. All right, so that will be my answer. 7 7,800 seconds. That's what I will get. This is the final answer. If you change 2 hours and 10 minutes, if you change it to seconds, you will get 7,800 seconds. All right, so that's the final answer for B. Let's go for C and solve that as well. So C should be, it says express 16, this one is easier, 16 gram, express it into microgram. All right, so because one of my units are single letters, so I don't need to do it in 2 steps. I'll just write down the input. I don't need to do it in 2 steps. That's the input multiplied by the division. In the denominator, I should have the same unit so that they can cancel each other. And my output should be in the numerator, so that's microgram. All right, so which one is my single letter? G is my single letter, so I have to write down the power next to it. 10 to the power what? Micro is -6, of course, but I don't need powers in the denominator, so I have to take it all the way up to the numerator. And when I take powers to the numerator, the signs will flip. So this is 16 multiplied by 10 to the power +6, because why +6? Because I took it up and the sign will flip. If it's negative, it becomes positive. If it's positive, it becomes negative. All right, so what is the output unit? It is microgram, so that will be my final answer. So 16 gram equals to how many micrograms? 16 gram equals to 16 multiplied by 10 to the power 6 microgram. That's how much it is. All right, so I'll leave the question 11 here. You guys try to solve D, E, and F. All right, so the next question will be question number 12. Let me solve question number 12 for you. All right, question number 12, it says use the SI prefixes to change those hypothetical units of measurement into appropriate quantities. So I've got some quantities. For example, A, it says 10 rations. 10 rations. It says change that into proper SI unit. Change it in, sorry, not proper SI units, proper SI prefixes. So I'll just change it to the prefixes. I'll just change the numbers, not the units. I don't even have units here actually. Prefixes. Okay, so I'll just change that number into a proper SI prefix. Now 10 is what is the proper SI prefix for 10? So that would be deca, right? If you remember, deca is the proper SI prefix for 10. So I'll just change it to deca. Here I'll write down deca rations. That's the correct answer, deca rations. Okay, what about B? At B I've got, what have I got? It says 2,000 mockingbirds. 2,000 mockingbirds. How am I going to change that? Mockingbirds. I think that's how you do it. Yeah, mockingbirds. So 2,000, it means, how much it means, 2,000. That means 2 kilos. 2 kilo mockingbirds. That's how you change. That's how you change it. This is, again, mockingbirds. I don't need to write it again. So that's B. What about C? So C I've got, let me turn the page. C, it says 10 to the power -6 phones. 10 to the -6 means micro. So I'll just write down microphones. That's what it means. What about D? D, it says 10 to the power 9 goats. So 10 to the power 9 means nano. So I'll just write down nano n, small n, goats. That means nano. All right. What about the final one, which is E? It says 10 to the power 18 minors. Okay, so let me change that. 10 to the power 18 means tetra, which is T capital, minors. That's it, tetra minors. So that's how you solve question number 8. Very easy. You just change the prefixes. Those numbers, you change them to SI prefixes, and that's it. Okay, so next I'll go to question number 14. Let me solve question number 14. Okay, on question number 14, it says you have an elevator. You have an elevator that is 1 multiplied by 10, that can carry 1 multiplied, so is it 1? Yeah, it is 1 multiplied by 10 to the power 3. This is 3 kilogram. That's how much it can carry. This elevator, it can carry 1,000 kilogram. Okay, 1,000 kilogram. That's how much it can lift up. And if each person is 85 kilogram, how many persons that this elevator can carry? So what are you going to do? You just simply divide the power of the elevator to the number of persons, okay, to the number of people that the elevator will carry. 1 multiplied by 10 to the power 3 kilogram divided by 85 kilogram. So that's what you have here. Now 1 multiplied by 10 to the power 3 is simply 1,000 kilogram over 85. So you just multiply 1,000 kilogram by 85. Now guys, you can see here I've got kilogram on the numerator, kilogram in the denominator. Those two will cancel each other out, so I'll just be left with numbers. That means that many number of people can enter the elevator without making any problem to the elevator, because that's how much it can carry. So if you multiply 1,000 by 85, I think you should get more than 11. So more than 11, less than 12. So I'll just write down approximately 11 people. That's how much the elevator can carry without having any troubles. More than that, it cannot carry it. It doesn't have power to carry that much. All right, let's go to question number 15. So I've got question number 15. It says, can a set of measurement be precise but not accurate? Yes, you can be precise without being accurate. How's that? If my true measurement is 10, for example, let's say that this is my true measurement, 10 meters. Okay, this is the true value. But when I do my measurements, I'll get 15.1, 15.2, 15.3. These are the measurements that I get, all of them in meters, by the way. Let me write down the meter here. That means this is for all of them. All right, 15.1 meters, 15.2 meters, 15.3 meters. So this is far away from the true value, so it is not accurate. My measurements are far away from the true value, so they are not accurate. But they are precise because they are close to each other. They are far away from the true value, that's true, but they are close to each other. So yes, they are precise. They are precise. So I have a measurement that's precise but not accurate, so this is possible because there's a degree of exactness. That's why. You have a degree of exactness without being your measurements to be close to the true value. So this is how you solve question number 15. Yes, it is possible to have a measurement that is precise but not accurate. All right, let's go to question number 16. In question number 16, it says how many significant figures are in the following measurements. So A, it says 300 million. Yeah, that's how much it is. Wait, let me not write down this. This is nothing. Okay, so meters per second. So how many significant figures I have here? Of course, I've only got one significant figure. These are all insignificant figures. Why is that? They are not significant because they come at the end, zeros that come at the end without having any decimals, they are not significant. So how many significant numbers I have? A, I've only got one significant number. What about B? At B, I have 25.030. So because I have a decimal, the zeros after the decimal will be significant. Let me write down this. This is C, Celsius. No problem. Just forget about that. So I've got 1, 2, 3, 4, 5. I've got 5 significant figures. All right. What about C? At C, I've got 0.06070. So that's Celsius again. How many significant numbers I have? Well, the zeros that are in front of non-zeros are not significant, so this is not significant, not significant, not significant. From here it starts 1, 2, 3, 4. I've got 4 significant figures. So that's C. What about D? D, it says 1.004. So zeros between non-zero numbers are significant. So I've got 4 significant figures. That was Joule, by the way, no problem. So let's go to the final one, which is E. I'll write down the E here. Let me write down E here. E is, it says 1.30520 megahertz. How many significant numbers you've got? Because you have the decimal, you have to count the zeros as significant figures as well. So that's 1, 2, 3, 4, 5, 6. I've got 6 significant figures. That's the final answer for question 16. All right, so let's move on to question number 18. Question number 18, it says you have a measurement, which is the speed of light. This is question 18, guys. The speed of light is 2.9979248, a very big number, multiplied by a very big power. So that's just for you to know how fast the speed of light is. This is the fastest thing in the universe. All right, so 2 multiplied by 10 to the power 8, that's a very big number. All right, so this is 2 multiplied by 10 to the power 8, and these are all the precision of our measurement. Okay, let's see. It says first, A, what should you do? Express the speed of light in the following ways. First, with 3 significant figures. I only need 3 significant figures here. I want to express the speed of light with 3 significant figures. All right, so those numbers are all significant figures because they are non-zero numbers. They are all significant figures. I don't need all of that. I only need 3 significant figures. So I'll just choose those 3 first numbers. I'll write down 2.99. That's my significant figures, okay? Now I can change that and write it in another way. I can change that into 3.00. That's also true, because this is approximately close to each other. 2.99 is equal to 3. All right, so because zeros after the decimal are significant figures, so now I have got 3 significant figures. And because it says express the speed of light, so I'll just multiply 10 to the power 8. Those 10 to the power 8 will not change my values of significant figures, because powers are not significant figures, meters per second. So that's all I've got. 1 significant figure, 2, and 3. That's it. So let me go to B. B, it says change it with 5 significant figures. So I'll do the same thing, but this time I'll choose 5 numbers. 1, 2, 3, 4, 5. Yeah, until here. I'll write down 2.9979. That's 5 significant figures. Okay, so that's 5 significant figures, again multiplied by 10 to the power 8. But I can write down in a better way. I can just write down 300. Yeah, 4 O's, because those will add to the 3. So this is approximately 3 multiplied by 10 to the power 8, with 4 zeros after the decimal. Again, those zeros are significant figures because I have a decimal here. Okay, what is the final one? The final one says with 7 significant figures. I can do the same thing. I can just write down C equals to 3.12345 6, that's 7, right? 1, 2, 3, 4, 5, 6, 7. That's 7 significant figures, 10 to the power 8 meters per second. That's if you want to do it approximately. And if you want to do it precisely, you can just choose 7 numbers here and leave it there. Why? Because I'll be left with 4, and 4 cannot add to the 2, right? 4 cannot add to the 2, so this will be left. So that's how this will be left as it is. So that's where you will that will be your final answer, multiplied to 10 to the power 8. You can write it down like this, or you can write it down like that, no problem. All right, so let's go to question number 19. Question number 19. So 19, it says how many significant figures are in the following measurements. So I've got A, which says 78.9 plus and minus 0.2. Now this plus and minus 0.2 meters, that's only the uncertainty of your measurement. We will not care about that part. We will only care about this part. So how many significant figures we have here? We have 3 significant figures, of course. 0.9 equals 3 significant figures, okay? So that's the correct answer, 3 significant figures. That's 1, 2, 3, because non-zero numbers are all significant. B, it says 3.788 multiplied by 10 to the power 9, which is giga seconds. All right, so powers are not significant figures. We will not count them. I have 4 significant figures here, that means, because they are non-zero, 1, 2, 3, 4. All right, let's go to C. It says 2.46 multiplied by 10 to the power 6 kilogram. Again, the power is not significant, so I'm left with 3 significant figures. That's C, which is 3 significant figures. What about the final one, D? D, I have 0.0032 millimeters. How many significant figures I have here? Those zeros in front of non-zeros are not significant. So I've only left with 2 significant figures, 32, 3 and 2. That's my 2 significant figures. So that's question number 19. And that would be it for now. I'll see if I'll continue with the other questions. All right, thank you guys for listening so far. I hope you got your answers right as well. I'll see you later.